Good morning, everyone. Our topic is Domain Name System Protocol or DNS system. It was introduced in 1983 by Paul Mokapetris to replace the outdated host.txt file system, which couldn't keep up with the growing interest. DNS acts like the internet's phone book. So, it translates domain names like youtube.com into IP addresses like 142.250.190.46, which computers need to locate web servers. This makes internet browsing easier and more intuitive for users, eliminating the need to remember numeric addresses. Also, a quick fact that the first registered domain was symbolics.com back in 1985. DNS protocols and functionalities. DNS operators operate using a client server model. So, when a user enters a website name, the client sends a request to a DNS server which responds to the correct IP address. It supports various record types such as A for IP addresses, MX for mail servers, and CNAME for aliases to handle different tasks in name resolution. Authoritative DNS servers provide the final unverified answers during this process. Each message follows a standard format defined in RFCs 1035, ensuring fast and reliable communication. So, DNS plays a foundational role in enabling smooth access to online resources.
Talking about DNS query types, first is TXT record. TXT stands for text. This record holds human readable text information. A common use case is to prevent email spoofing. Next is the A record. It maps domain name like google.com to an IPv4 address. Next is the AAAA record, which is specifically for IPv6 addresses. Third is the MX record. MX stands for mail exchange. This record tells the internet where to deliver emails sent to a domain. Next is the CNAME record, which is short for canonical name. This record lets a domain act as an alias for another domain. Next is the NS record. This stands for name server. It indicates the name servers for a particular domain. Now talking about DNS rules. DNS runs on UDP 453 for most queries, which is fast and connectionless. It uses TCP 453 for zone transfer and large queries. DNS messages follow a standard format that is defined in RFC 1035. DNS is also case insensitive for domain names, such as google.com with a capital G equals google.com with a small case g. Resolvers that are clients here send queries to DNS servers, and thus servers respond with particular answers. Next is talking about DNS messages. So this involves query, that is the request sent by the client to resolve a domain name. It contains domain name and query type as we discussed previously, that is A, AAA, MX, or CN. Next is the response. The response is sent by the server with the answer or an error message. Thank you.
All right. So DNS is already pretty awesome, right? But did you know it's still evolving with the time? Take DNS over HTTPS or DOH. It's like giving your DNS request a private tunnel with bodyguards. Hackers can't snoop, and your privacy gets a major upgrade. Then there's the blockchain DNS, yeah, like with like.edh, where your web domain lives on the Ethereum blockchain. You're the boss, no central registration, no expiry date. It's decentralized, secure, and the future of how we'll own domain. Okay, these are the OSI layer and transport. Now zooming into the where DNS sits in the big picture, the OSI model. DNS lives in the application layer, right at the top where all the human interaction stuff happens. For communication, it usually uses UDP, which is very fast, doesn't wait around for handshakes, but if the message is too big or important, it switches to TCP, which is a little slower but reliable, like moving from casual texting to a proper clear voice call. Fun fact, hackers even try to exploit the switch to overload DNS server. These are the application of DNS. So what does DNS actually do in our daily life? A lot. It translates name into IPS so website loads, sure, but it also rotates emails, help Netflix and YouTube stream smoothly via CDNS, balances traffic so servers don't crash, and blocks malicious websites. It even connects your smart gadgets like your fridge and your doorbell to the cloud and the powers VPNs to sneak past restrictions. Basically, DNS is the quiet genius keeping your internet life seamless and safe.
Talking about the interesting case study on DNS protocol. The 2016 DYN DNS outage was a watershed moment in internet history. On October 21st, a massive DDoS attack powered by the Mirai botnet flooded DYN servers with traffic from compromised IoT devices, hitting major platforms like Twitter, Netflix, and Reddit. This wasn't just a temporary disruption, it exposed our critical vulnerabilities in our digital infrastructure. The attack revealed two key weaknesses: the risk of centralized DNS architecture and the alarming insecurity of IoT ecosystems. But it also spurred innovation. In response, the industry adopted robust countermeasures, distributed DNS services, DNSC for authentication, and stricter IoT security protocols. Today, DNS is evolving beyond its foundational role with advancements like DNS over HTTPS and Anycast routing. It's not just about reliability, it's about privacy, speed, and resilience. The DYN outage taught us that DNS isn't just a technical protocol, it's a cornerstone of global connectivity. And as cyber threats grow more sophisticated, so too must our defenses, because when DNS fails, the internet stumbles. Here we have provided you with some resources, which are publications from the IEEE journal. As we have seen, DNS is far more than a protocol. It is a silent guardian of a digital age. Thank you.